Thanks everyone for joining us today in our opening session for this webinar season. We're starting with a pretty high level discussion today to kick off this season, but we do have a lot of great speakers coming up throughout the season. The Zoom registration links are available on our website, so you can go ahead and get registered now. So that's on your calendar. I'd highly recommend you check that out, but I would uh, definitely encourage you to be a regular on our webinars this season if you aren't already. So as the title implies, we're talking a little bit about risks today. I would anticipate a good amount of discussion in today's session. I would also anticipate we might stick around for a few minutes beyond the 2 o'clock mark if we need to wrap up some discussion. But I'm looking forward to getting your input as we go through this together. You see some information about AIA here. Also on your screen now, you see the description for this session. Hopefully you had a chance to look at it. It's pretty general, just talking about the challenges associated with a modern building enclosure. It presents a lot of risks. Certainly building professionals, builders and design professionals understand that this is an industry that carries with it quite a bit of risk. But what we're going to dive into today is risk as it is associated with the building enclosure, but also more specifically than that, as it relates to the code compliance process. So we have some learning objectives that are being shown now. The 4 learning objectives do a good job of summarizing this as well. We're going to describe some general types of risk, not going to be a comprehensive approach. I will say I talked to some folks. I know at least one is on the webinar today watching, who said, "Why are you trying to do this in an hour?" And I didn't really have a good answer for them because certainly this is a wide discussion. But certainly we're going to cover a couple different types of risk that I see quite often being a big factor in how buildings are designed and constructed. We're going to look at how plan review and inspection processes may influence this risk mitigation and risk tolerance. We'll look at some strategies as well to ensure some proper performance. We're going to give some recommendations to those tuned in. And then ultimately, we're going to try to avoid those building enclosure failures because those implications are pretty profound. So we're going to attack this from a couple of different angles, but I just want to take a moment to talk about what I think our goal should be for today. Chris and I, we celebrated, I don't know that we celebrated properly. We should have had a much larger celebration than we did, but we've been at the PHRC for a decade now. And this webinar is really born out of the experiences, the anecdotes that we've heard over that 10-year period. And I think ultimately, though, regardless of what I'm bringing to this discussion, I think that our industry is in a really important and interesting point in the trajectory of how we build. I think that the modern residential structure, we're looking at all of this through the lens of the IRC. So, a lot of single family and some attached housing as well. We're at a point now where I think a lot of the builders that we interact with, looking at the Pennsylvania and the regional market, they've adapted to some of the more significant changes that we've seen. A lot of them that have come through code compliance changes under the Uniform Construction Code. And, we're still seeing challenges coming out of some of those code changes, but I think in large part, we've gotten over some of those hurdles and are at the point where I think we can begin to reinforce our approach to how we design and build. And I think that there are two main benefits to this idea of reinforcing our approach. And the first one is, I think we need to better understand the assemblies that we're building. I know oftentimes we run into folks who are in almost triage mode with the code compliance process, which is just get me through to get my CO. But then I think it's important to be able to understand more deeply the way that we build, regardless of the reason why we build that way. And the main reasons, I think, are because we need to be able to adapt them oftentimes on very short notice. Some examples of maybe some external forces that would prompt some of that adaptation would be changes in subcontractors in your labor force, material changes, material options, cost increases and cost changes. There are a lot of reasons why we may have a design in mind that is code compliant, but they need to be modified in some way or another that may introduce some additional risk. And I think that deeper understanding of the reasons why we're building the way we build would help to reinforce our approach to that process to keep that risk at bay. And then I think the second reason why reinforcing our approach is important right now is it's really the idea of preparing for the future. We're not at a plateau in energy code and just code in general stringency. I think there is a likelihood within the next couple of years, specifically looking at the code review process that Pennsylvania is undergoing right now. It's entirely likely that there will be some code changes that get adopted that will prompt some additional changes to the way that we build our building enclosure. And I feel that it's really important to shore up the processes we have in place so that when we navigate those processes as a design community, or sorry, as a building community, we're prepared for a lot of those significant changes. That might seem very vague right now, but that's really what the emphasis is going to be today. Giving some examples. We're going to have 4 examples today where we're going to try to dive into this and talk about what I think might be prompting some additional consideration in the way we build. But with that in mind, I do want to take a moment and talk just more broadly. What are we referring to as the building enclosure? And while this might seem like a really vague definition that you see on the screen by John Straub, his definition being that part of any building that physically separates the exterior environment from the interior environment, we're calling that the building enclosure, the building envelope. I really just want to reinforce the fact that the building enclosure is not defined by 1 or 2 components. It's really defined by assemblies and systems. And we see that when we start to look at the way we build. A simple cross-section of a 2-story single-family dwelling, we can see by what we have highlighted here, we may be defining our control layers when it comes to thermal control or our air barriers, but we may encounter a lot of interruptions to that with things like additional details at our roof to wall intersections, at our overhangs, our foundation and rimboard details. It's a very complex system. And I think when we look at how this intersects with code compliance, some of these things are going to be determined or dictated by code compliance. And many of them, though, are going to be under what we'll refer to as best practice. You may have a way that you build that works. And ultimately, though, that should be defined by your performance goals and the product you're building. But in general, we see times in the world of code compliance and building structures where best practice and code compliance, minimum code compliance, I should say, are aligned. And we see many other times, and I'm sure you may all be aware, have other times where they're pretty far apart. So we're going to try to acknowledge that when we go through today. Oftentimes, and you may have seen this before in some of our other sessions, we'd like to define the building enclosure by 4 functions that we are trying to accomplish within that building enclosure. We list them in a bit of a subjective order of importance, starting with structural support, and then living in that second bullet point, which is our control function, looking at heat, air, and moisture as our primary control functions, but also understanding that smoke, odor, sound, fire, insects, etc., are really critical and important elements of that control function as well. But we certainly can't forget those 3rd and 4th functions also, which is aesthetics, our interior and exterior finishes, but also how the intersection of those other 3 goals with our distribution of services, mechanical, electrical, plumbing, are going to present their own challenges. So again, what I'm trying to point out, and I'll try to illustrate it with the photo you see on the screen, this photo is of a 4-unit building. Now, certainly this gets a little bit more complicated as to the code compliance side, but what I'm trying to point out here is some examples of when design is required that might go above and beyond code, and when code minimum compliance is dictating how the structure is built. Some examples: egress, safety, when it comes to your guard heights, your guard construction, and so on and so forth. That's primarily driven by our code compliance goals. But I often will show this picture in our moisture management courses when we talk about overhangs, and the fact that nearly every punched opening in our building enclosure and our walls is protected by some amount of overhang. That's not a code compliance issue. That's a design choice. So again, just trying to acknowledge that there is a lot at play when we are designing and building our enclosure, and we're going to spend some time today really digging deeper into the code compliance aspect. Another example, a photo taken of, this is actually a home. This is an interior shot of a home in the area surrounding Las Vegas. We had an opportunity to tour development when we were visiting for the Builder Show. And interestingly enough, our competition team is designing a residential subdivision that will build similar structures in their product. Nonetheless, we're still seeing some contrast, some alignment, but also some um, diverging of goals when it comes to code minimum and design choices. You know, your code minimum uh, requirements for things like U factor in your glazing, your code minimum requirements for safety glazing in certain areas where glazing is close to certain surfaces. As a code-driven choice when it comes to the construction of this building. But as you can see in this photo, you know, you're in the desert. You're going to have some daylighting concerns, maybe some overheating concerns with your HVAC design that gets beyond code minimum compliance, and we start getting into design. So really what I'm trying to acknowledge in this introductory discussion is when it comes to the building enclosure, there are two really key goals at play, which is trying to design to meet the goals of the project and to meet client expectations and budget and so on and so forth, but also trying to navigate the code compliance process. Like I said before, there are many times where these align. There are other times where you go above and beyond what may get you through the code process in order to meet the goals of the project. Ultimately, because we're talking about the built environment, we have to talk about risk. So within the building enclosure specifically, I just want to briefly acknowledge two different types of risk with the building enclosure. The first one would be performance. Ultimately, the building enclosure, the assemblies that go into that, the materials and systems need to meet a performance level based on the goals of the project. Sometimes that performance level is going to closely align perhaps with a code minimum performance level. Other times you'll see where the performance is a much higher expectation. We will often see this being defined by above code programs or even just generally beyond code goals. The second one, though, aside from performance, so I should say performance can mean a lot of things. Performance can be defined by metrics such as energy consumption, certainly influenced by occupant behavior and choices. But generally speaking, you know, performance is going to take on a lot of different perspectives. But the second one is durability, and I think that's where we start to see things complicated with a building enclosure, which is a properly designed and built building enclosure should be durable within certain objective limits of materials and systems. We shouldn't be expecting to see things fail prematurely if we've met our durability and performance goals. There are other much more detailed risks within the building enclosure, but I mentioned these two so that we can continue through our discussion today. But like I said, this is opening up a pretty big discussion point overall. So more specifically, if we're trying to acknowledge that navigating the code compliance process is going to introduce perhaps a bit of risk for mainly the builders and the design professionals, I've defined two different specific types of risk. Again, not trying to portray these as a comprehensive list, but I'm going to refer to these as false equivalency and mistaken identity. So if I had to summarize these, and we're going to spend our time today digging deep into both of these, but if I had to summarize them, the false equivalency is assuming minimum code compliance is an adequate substitute for proper design. Now, we'll have some disclaimers about this in a moment, but I want to summarize it in that manner. The second one is mistaken identity. To summarize this, assuming plan reviewers and inspectors are performing quality control functions. Now, perhaps your response to hearing that is, that's not me. That's not how I build. That's not how our company builds. And I understand that. Which brings me to my disclaimer slide. It's always fun to have a disclaimer slide in any of our webinars. But I really want to give you, again, a little bit of background into why we're having this discussion. The idea of building enclosure risk was brought up in a discussion with our advisory council earlier in 2023. And I believe that a lot of the origins of that discussion came from what has really been a collective uh, or a collection of anecdotes and observations. In my own personal experience over the past 10 years, our team over a collection of many years, which is trying to understand what is challenging the residential construction industry most in our current market. Because ultimately, the goal of the PHRC is to identify challenges facing the market and meet our constituents and our audience within those challenges to try to help them out of those or help them tackle those. So really, this webinar is rooted in less in objective data and more in smaller sample size anecdotes and observations, which ultimately means that some of you may not share the same experiences. If you get to the end of this webinar and feel like you are in great shape and none of the risks that are brought up may warrant any additional consideration, I think that's great, and I hope that ultimately that you enjoyed the hour you spent with us. But I would suspect that everyone that's tuning in today might be prompted by some of this discussion to at least ask some questions, and maybe those questions are being asked to yourself, but perhaps those questions are being asked to your team. Because I feel like we do a lot of assuming in home building. I know I did it when I was designing and building homes, and we are often confident that those assumptions will hold true. But like I said before, we're at an interesting point in this industry where things are changing pretty rapidly, and our labor force is one of those things that's changing. Material selection, material pricing, all those things, they're going to prompt these external forces to perhaps challenge those assumptions. So I would encourage, again, the goal today to be to reinforce the way that we approach the building enclosure, so that as things continue to change, we're in a good position to be able to navigate those processes. And certainly, as you hear something and you may agree or disagree, that's a chance to politely disagree in the Q&A and chat, and then we'll have a discussion together. So with that being said, we're going to talk first about false equivalency. And as a reminder, what I said before, I'm going to summarize this based on what I have seen time and time again with the folks that I've talked to. I've talked to a lot of code officials about this as well. But it's the idea that if my building and my assemblies are code compliant, then I'm good to go. And excluding or eliminating the need for true design. So it's assuming the minimum code compliance is an adequate substitute for proper design. Now, perhaps this is an exaggeration, right? To truly throw up your hands and say, I don't need to design is probably a rare occasion. But the idea is that I can pull back in some manner from the design process, reduce my emphasis on design, because I'm relying on what has become an increasingly stringent code compliance landscape. And I think that there's some amount of that attitude that's probably fairly common in a lot of projects, whether we like to admit it or not. And again, this is not based on hard data as much as it's based on observation and anecdotal evidence over the past 10 years that I've had in this industry. So let's take a look, sort of, setting the landscape a bit more, and what you see on the screen are some images of our code books. We're looking at the Uniform Construction Code, specifically at the Energy Code, and we'll use this to illustrate some points here. We know that the Uniform Construction Code in Pennsylvania, we're enforcing the 2018 International Residential Code as our base code. Also, the residential provisions out of the IECC and the 2021 Pennsylvania Alternative. That lays out the way that we navigate the Energy Code, and the Energy Code has a pretty big influence on the building enclosure overall. In Pennsylvania specifically, we start to dig a little bit further and understand that often prescriptive, not everyone follows prescriptive, but generally prescriptive requirements within the Energy Code are really dictating how some builders and design professionals are building and designing. So we have our climate zones 4, 5, and 6 in the climate zone map that you see on the screen. Certainly, we're going to cherry pick some more complex requirements in the prescriptive code to try to illustrate some points. But again, to broaden this application of our discussion today, we're not at a plateau for energy code stringency. It's likely that we'll be encountering additional challenges once we see what's adopted in the Uniform Construction Code out of the 2021 review. And then digging a little bit deeper into our prescriptive approach in the 2018 IRC Table 11 and 1102.1.2, we see the insulation and fenestration requirements for zones 4, 5, and 6 highlighted for everything from fenestration through slabs and crawl spaces. There are some assemblies in here that present risk if you don't pair a design process with an understanding of what needs to be done for code compliance. And we've had these discussions over our years of training as these code changes have come through. But again, the general idea here is acknowledging bigger picture. What's the role of design in this overall process? So to broaden the scope a bit, we're kind of zooming in and zooming out as we go through this discussion. The Department of Energy has a chart here that's estimating the improvement, or I guess you could say efficiency of the residential and commercial energy codes. I'm going to look specifically at residential as defined in the blue line. We've come a long way in not an entirely long amount of time in terms of stringency in the energy codes. And there are a lot of reasons for that. There's certainly a lot of benefits to that. But my argument here is that we've started to see a lot of things converge in how a builder might view what many call minimum code compliance as being the worst way that, or I should say that, yeah, the worst way that you can build a house legally. Not my words. Again, I've heard these from many folks. What I would argue is that as these codes as the energy codes have become more stringent, we've encountered fewer and fewer builders, and I know they are out there, but again, I'm speaking to our experiences. We've encountered fewer and fewer who claim to be above code builders. And what I mean by that is, a lot of builders, if I back up one slide, a lot more builders today use the values you see in this table to define the specs on their cross-section of their home than perhaps 10 or 20 years ago. And I'm not saying that that's good or bad, but what I'm trying to say is there's some risk that's associated with that as we try to continue to navigate this process. So I'm going to share, I have worked for 10 years to avoid sharing many opinions, but I'm going to share, I would say, more of an interpretation of what I see a lot of builders running into as far as challenges, which is the idea that as code minimum and accepted best practice converge, what I've seen is that builders and design professionals, there's a tendency to view enforceable building codes as design guidance. And some code compliant outcomes, many are aware, carry tangible amounts of risk. And so to kind of flip that a little bit, I would argue that the larger the gap between code minimum and accepted best practice, the greater the need, or I should say, the greater the perceived need for design. Now, again, if you're reacting to this and saying, well, I'm so far above code that doesn't apply to me, then in many cases, you're getting into a whole new world of risk because some of those complex systems you may be encountering are really incorporating new materials and new systems. But again, it's just this idea that the convergence of code minimum with what many see as best practice presents challenges in the way that we approach the building and design process. I think one of the contributors to the risk that we see is actually not related to energy, but it's related to moisture. We can't forget about moisture. And I've shown these statements before in a lot of the training that we do. And just to generally summarize, as residential buildings have become more energy efficient, the enclosure is becoming more sensitive to moisture-related damage. We've seen this time and time again, on singular examples or more broad examples, like we've seen in issues that we've faced with things like hard coat plaster, stucco, and stone. But just to summarize it, the airflow and the heat flow that we've had through buildings in the past when buildings were less efficient and less airtight. The airflow that we used to have, the heat that we used to have, used to provide some insurance against moisture-related damage because you had some drying of your walls by that passing through of air and heat. So having less heat and ventilation, available within our assemblies, or I should say airflow available to provide that drying, maybe unintentional drying, let's say, means that it puts more emphasis on how we build our buildings. We have to get our details right because we're trying to comply with a more stringent approach to building. Now, to look at it a different way, if we want the benefits of a more energy efficient building, we have to make sure that we get a lot of these other enclosure details, get them right the first time. So what we don't want to see is what we commonly were looking at in parts of Pennsylvania that face the stucco and stone issues more rampantly, which was buildings that are under 10 years old having moisture-related damage where your wood-based products got to a moisture level that was unsustainable. And we saw rot in things like OSB, but even our solid sawn rim board and our bottom plates. Again, just trying to acknowledge that there's some risk there and not seeing this from a fully comprehensive manner. I'm not saying that codes are the reason why this failed. What I'm trying to say is that a more airtight, more energy efficient building meant that these systems were a little bit more sensitive if you didn't get the details done right the first time. So let's look at an example. And I'm going to, like I said, use 4 examples as we go through this. The first example has to do with assembly drying potential above grade. So what I'm trying to acknowledge is that, again, there's some specific scenarios where if you're not properly pairing design with a code compliance process, you may run into some risk. So some options for above grade wall assemblies might lead you to an energy or to a code compliant wall assembly that includes exterior vapor retarders or vapor barriers, such as foil-faced foam, to satisfy your exterior insulation requirements, that also have a requirement for an interior vapor retarder of a class 2 or a class 1, which would be a vapor barrier, such as craft paper or poly. If you're familiar with why that's a bad thing, we need to really dive deeper into drying potential, which we will in a moment. Under the current enforceable code, the prescriptive requirements for climate zone 6 require or give you an option of a 20+5, so R20 in a wall cavity and then an R5 continuous on the exterior of a wall. I want to dig deeper into that to see where the risk comes from in that example. But I do need to define what I mean by drying potential. When we look at our building enclosure assemblies, we have to assume they're going to get wet. They will absolutely get wet. I will say that the example of the building that I'm in, which is a building that's actually on the docket to be torn down. So we're on our last legs here in Sackett Building. I know that there's moisture that gets in these walls, but in all of our building assemblies, we have to assume some level of moisture will be present, but then we have to accommodate that by making sure that it can dry. So we can do that through source control, occupant behavior as much as we can influence, but also generally assembly design, so material specs and system specs. They need to be designed so that they can dry to the interior, to the exterior, or both. You need to allow these assemblies to dry in one way or the other. So we can look at exterior continuous insulation and understand that there's a benefit there from a thermal bridging standpoint. You're not eating your sweater, you're wearing it, as they say. So that exterior layer, not always foam, but sometimes and many times foam, will provide some additional R value over top of your framing as well as over top of your wall cavities. So we understand that there's an energy benefit there, but there's some additional risk when it comes to condensation control and drying potential. So like I'd said, there's only one climate zone currently in Pennsylvania out of the 2018 insulation and fenestration table that requires it prescriptively within the IRC or IECC. We're not talking PA alternative just yet. That 20+5 option is an option that many have acknowledged carries some additional risk. So let's dive into that a little bit. The table that you see on the screen comes from a Building Science Corporation document. There's a link on the bottom. I know you can't click on the screen, but in the handouts, it's an active hyperlink. I'd encourage you to read the document if you're interested. But they have recommendations in this document for minimum levels of exterior insulation for condensation control. The idea is that if you're sheathing your building and then you're applying exterior insulation on the outside, you want to warm the interior surface of your sheathing to a point where condensation is a lower risk. So what we see here in climate zone 6, if you have a 2x4 cavity with an R13, and then you have, you would be looking at a recommendation of an R7.5 on the exterior, which amounts to a 35% ratio. If you have a 2x6 wall, R20 insulation minimum, you'd be looking at a recommendation of R11.25. Both of those values are greater than 5, and certainly when it comes to the 2x6 value, with a recommendation of 35%, 11.25 is more than double what that prescriptive option includes. So this recommendation within this document is already acknowledging that you would need to include additional exterior insulation to begin to accommodate condensation control. If we dig into some of the reasons why this may carry some risk. In climate zones 5 and above, we're looking at the requirement for a class 1 or 2 vapor retarder. In section 702.7.1, there's some additional considerations for dropping your interior vapor retarding layer to a class 3. So a class 3 vapor retarder would be more vapor open, and that's permitted in certain instances. And when it comes to introducing exterior insulation, if you're using a material like a foil-faced foam or even an extruded polystyrene, those are either going to be vapor retarders or even vapor barriers in the case of foil facing. So we're not going to be drying to the exterior at a high enough rate that we may desire, meaning we're going to want to maximize our interior drying potential. So the idea of dropping to a class 3, allowing our drying to occur to the interior, is desirable. If we look at the table that's associated with that section, looking down at climate zone 6, we're looking specifically at the 2x6 wall. So we're just looking at the last line, and it says you can drop to prescriptively a class 3 vapor retarder if you have continuous insulation with an R value greater than 11.25 over a 2x6 wall. So what you end up with as prescriptive requirements for code compliance, if you choose the option where it's required of 20 plus 5, it would mean that you could have a code compliant assembly that has foil-faced foam on the exterior and still have a class 1 or 2 vapor retarder on the interior. And that presents challenges. There are a lot of ways out of that scenario. But what I'm trying to acknowledge is that even though that option may be code compliant, it may diverge from best practice. So my recommendations when you're considering this idea of above grade drying potential would be to select materials with an eye toward drying potential. There are materials that are more vapor open that you could include that would qualify or that would function as continuous exterior insulation. Also, exterior continuous insulation thickness should consider condensation potential. There are a lot of resources that can help you through that, including the document I shared. But what I'm trying to say is, well, I'll have some additional recommendations here in a moment. And then the last one, again, view code compliance is only one step in the assembly design process. One thing that I think is important to consider is that it's tempting, based on what I've heard from builders we've talked to, it's tempting for some to see a requirement for exterior insulation as if that's something they're not already doing. Some may look at it and say, what is the least disruption to my process that will get me through code? And for some that are already building with 2x6 walls, what they may see as the least amount of disruption would be to add R5 to the exterior and leave everything else the same. While that might be code compliant, what I'm trying to acknowledge here is that that carries risk when it comes to what you're doing to the drying potential of that wall. I'm not saying that it is a guaranteed failure, but I'm acknowledging that your risk goes up while code compliance remains the same. So these recommendations are really, that needs to be designed, not just selected. Okay. So let's keep going here. I have talked to a few people today about how much I talk a lot. So I should have known that I would probably be a bit long-winded with this discussion. But let's look at example number 2. Still talking about assembly drying potential, but let's go below grade. There are a whole host of challenges when you get to below grade wall assemblies, both in new construction and also in existing construction. But when it comes to below grade wall assemblies, there are some options that can lead you down a path that presents some challenges when you're looking at what's code compliant versus what's best practice. So, there are some common options where you would have an interior vapor retarding layer or vapor barrier without proper condensation control or air sealing. And what I mean by that is introducing a vapor retarding layer perhaps on the interior face of wall framing without properly preventing that interior moisture laden air from getting into your wall assembly and finding cold surfaces in your foundation wall assembly. So let's look at it a little bit further. More specifically, in zones 4, 5, and 6, we have requirements for basement wall R value of 10/13 or 15/19. So those numbers, the first number represents your continuous R value requirement if you aren't insulating wall cavities. Second number would be if you frame a wall and insulate your cavities. So, looking at what we see as common options here, in zones 5 and 6, you'd be looking at, as an example, 3 inches of extruded polystyrene R5 per inch, or a 2x6 wall with a minimum R19 in the cavity. The challenge that we see all the time is trying to determine what's going to be a proper balance of cost, constructability, and ultimately proper best practice consideration in this assembly. What we've seen really as recommendations for best practice here is essentially acknowledging that once you're away from the wall, you really need to prevent any moisture that might be within the wall assembly from getting trapped. And what I mean is if you're insulating that wall with air permeable insulation, so something like fiberglass batt insulation, you really shouldn't be putting anything on the interior face that would be trapping that moisture, slowing down the rate of vapor diffusion, if you can avoid it. So it's okay to include vapor retarders or even vapor barriers based on a lot of recommendations if it's in direct contact with the wall. That wall does not have to dry. That wall can stay at an elevated moisture content. But once you get away from it being in permanent contact with that wall, any moisture that's in that wall assembly, it needs to be allowed to come right in. So again, once interior from the foundation wall, layers should be selected that are generally vapor open. And to look at some code context for this, we have that requirement in 702.7 of a class 1 or 2 vapor retarder being required in zones 5 and above. They do offer exceptions for below grade portions or a basement wall, but they don't require the elimination of that vapor retarder. So what I mean is it's entirely code compliant to do what we just said you shouldn't do, which would be to include a vapor retarding or vapor barrier layer on the interior of perhaps a framed wall, and then have air permeable insulation behind it without proper condensation control. And here's a great quote coming out of a PNNL document, which is, if water vapor is allowed to pass through the below grade wall and the insulation, it must be allowed to dry to the inside of the home to avoid condensation in the wall cavity. It's really important to, again, consider beyond just what gets you through the code process and, what may be the best practice from a moisture standpoint. So some recommendations here, ultimately using moisture tolerant materials in contact with your foundation walls. That's just a broad recommendation. But generally speaking, once air permeable insulation is included, you need to avoid interior vapor retarding layers. But there's another recommendation here is to look at condensation control. Design that wall assembly so that the farthest into your wall assembly that your moisture-laden air can come in contact with is not going to be below your dew point of your environment. And that will help you to avoid those condensation issues. So generally speaking, when we're looking at this idea of false equivalency, my recommendation is to bring back more of a design focus into the overall residential construction process. And I'm not saying architectural design, and I'm not saying that this is uniform across the board. But when it comes to the building enclosure, if you're not intentionally designing, someone's going to be unintentionally designing for you. meaning that really you need to approach the building enclosure with a design mentality, not a checklist mentality. Getting through the code compliance process is not an adequate substitute for properly designing it to make sure that you're looking at those risks of performance and durability. And ultimately, someone needs to be responsible for the design of the building enclosure assemblies. I'm not going to tell you who that is. I'll tell you probably it shouldn't be your code official. I know there's some code officials who do their best to try to acknowledge what you shouldn't be doing, that even though it might be code compliant, they see a lot and they offer those recommendations. But really, in many cases, you should be bringing someone into the team and defining their scope of work to be designing this properly to mitigate risk. All right, I think there's some questions we'll answer as we go through. There's some great responses as well. I won't be able to necessarily acknowledge all of them, but we'll do what I can. I will say if there's any questions that you have that I don't get a chance to answer live here, please email me. I'd love to have a conversation with you. So our second risk that we're going to talk about, and granted, we're not halfway through, we're more like 2/3, so I'm not that late in my timing. I'm going to describe this as mistaken identity. And I summarized this before as assuming plan reviewers and inspectors are performing quality control functions. I think this is a really broad conversation to have, and I really think that each of you may be looking at this through maybe a different lens. What I'm trying to say is someone on your project, if you're a builder or design professional, someone needs to have eyes on the quality of installation. And again, I think this is really born out of the challenges we're facing in this industry, which is, hiring a new subcontractor, or that new subcontractor hiring new laborers, or getting a new design professional in. All of those changes can introduce that additional variable that might disrupt what you may have taken for granted before. So again, it comes back to making an assumption that quality, or that the quality is adequate, but assuming maybe that the inspector is going to be having eyes on it for you in case something goes wrong. And again, not every one of you is going to share the same mentality, but I think to a certain extent, you have to almost run through these hypotheticals. So, if you're a builder and you hire a new subcontractor for your enclosure, or do you have procedures in place to ensure that they're using the right materials and they're following manufacturer instructions? And I think that's the example we're going to show, really. So I'm going to say this, and perhaps there'd be folks that would have different definitions of what the code official should be doing. But I think the primary role of a code official, when I'm approaching my relationship with a code official, is they're providing reasonable assurance of compliance with enforceable codes. There's an inherent spot check approach to a lot of the inspection processes, just because of the overall breadth of items that need to be code compliant, which again means that you can't assume that if there was an issue that it will be flagged on your inspection report, because at some point, if you make that assumption, you're assigning them with a quality control function that they really aren't there to perform. So if I give you an example, it's one that I think many of you see. You can even say you see it on your competitors' jobs when you drive by. You don't have to admit that it's on yours. But there are times when using proprietary materials presents a challenge because you're jumping outside of the code, right? The code may be generically telling you that manufacturer instructions are important and must be complied with, but the actual installation of that, it really needs to be reinforced with an understanding of how the manufacturer wants you to install that product. Some manufacturers do a great job of going above and beyond to make sure that some contractors understand that process. But just in general, I'm trying to acknowledge here that proprietary materials require adherence to something that's outside of the code book. So, some challenges can arise there when we're looking at material compatibility. I'm really starting to get into specifically the water resistant barrier, your drainage plane. There are a lot of new materials that continue to come on the market. It's one of my favorite things to look at the International Builder Show every year, just to see what the new tapes and liquid flashing products and new wraps are. But that is inherently introducing variability, complexity, change. And I think that is, in this context of this discussion, is really, it's reinforcing that we need to take a look at how we approach this. I think in Pennsylvania, it's also interesting because the water-resistant barrier is not a required inspection item under the Uniform Construction Code. So some municipalities may include it, but even if you're assuming that a code official will, perhaps flag you on an issue if something's done wrong, but that's not even a required inspection. That's even further removed from what reality may be. So just showing you an example, and to be entirely clear here, I'm not making comments about any of the manufacturers being shown here, but what I am acknowledging is that there is a tape being used that's made by one manufacturer that's being applied to a wrap that's manufactured by a different manufacturer. It's not uncommon to see a mix and match of materials from different manufacturers, and sometimes it will be approved by that manufacturer. In this case, it would be the wrap itself. That water-resistant barrier manufacturer is the one that would ultimately say, here's the list of our approved products to be used to flash your openings and to seal your joints and seams. But what I'm trying to acknowledge is that who's responsible to make sure that these things are being done right? If a new subcontractor shows up and they're used to using a different system, and maybe they have leftover products from a different job, and if they take the mentality of, it works over here, it might work over here, there needs to be a little bit more of a communication and quality control process in place to make sure that that doesn't lead to issues down the road. So the recommendations that I'll try to show you here really just come down to a communications task, which is making sure that someone is verifying compatibility and communicating those material specs to subcontractors. And I talked specifically to a code official about this. Hypothetically, is that something you look at when you're going out to the site? If you happen to see a job at that stage of construction, and it was an interesting discussion just to hear, perhaps they'd say something to the builder, but it's really not the code official's job either to understand the complexity of some of those manufacturer installation instructions. There's just needs to be a little bit more communication here, because again, as proprietary materials keep coming on the market, I think it's really important that quality control is better defined on our projects. I'm again also tying this back to exterior insulation. There's a chance that more climate zones in Pennsylvania are going to be required to install continuous exterior insulation. That's going to introduce an entirely new body of options when it comes to different materials and whether or not they're compliable or they're compatible, excuse me, with different tapes and sealants. Those are things that need to be investigated, and communication needs to happen. So in the time I have left, I just want to acknowledge one other example, and this kind of goes to a slightly different approach, but it's ultimately related to code compliance and a risk in the building enclosure. And we hear this quite a bit. There's some areas of the state where blower door testing is not a required task, meaning that in new construction, to get through the requirements for code compliance in the building enclosure from an airtightness standpoint, there are some code officials that are not asking for the results of a blower door test. I'm not here to tell a code official what to do or what not to do, but we get questions a lot from a builder saying, if I'm not required to show the result of the test, am I still required to meet the requirement? Running the test doesn't do any air sealing for you, but it's verification that you met the 3ACH50 requirement for the structure. So our general recommendation in this instance is that yes, you are still required to meet the intent of that section, and ultimately, if you deliver a product that is not airtight to the level of 3ACH50 or less, but you were able to pass your inspection because you were not required to show proof of that, I think that presents a challenge to not make sure, to not verify that the 3ACH50 is something that's complied with. So again, it's just representing this idea that, what are we seeing as validation of the design and construction process as it comes through the code compliance process? I think there needs to be sort of a broader approach to this that includes a lot of design and sometimes might even be in direct conflict with code requirement or what the code official is asking for. So just to take a moment to review, and then I'll dive into questions. I know I'm coming up on 2 o'clock. Building And the building process and the design process is inherently laced with risk. We understand that that's just part of the job. But when it comes to approaching the building enclosure and the conditions that we're in right now in our market, I think that there are some specific risks if you don't take what I would argue is a proper approach to the code compliance process. Again, I think making the assumptions that code compliance is an adequate substitute for proper design or some amount of that, I think is going to present more risk to you. And also assuming the plan reviewers and inspectors are performing quality control without also ensuring you have a robust quality control system in place, I think also presents some additional risk. But ultimately, my recommendation in response to this, I think, is it really should prompt some self-reflection, some evaluation of the way that you build and design. And again, the fewer assumptions that you make, I think the better off you'll be. And you may be fine now. And again, you may walk away from this webinar saying, those are not my problems. But I think you should consider, well, is there any possibility that it could become my problem? Because you can't always assume that things will go well. I think small changes can have big outcomes. We've talked about what these changes could be. And these aren't just me dreaming up what these problems might be. This comes from conversation after conversation of what a builder or a code official or a design professional has run into in the field, saying, hey, I don't know how we got here. And then we dive into it and we acknowledge that some of these changes that the old conditions used to lead to success might present some challenges that need to be navigated. So ultimately, the rest of our season this year, and ultimately the goal of the PHRC is to support you through challenges, whether they relate to the building closure or not. So I hope that you see this as an opportunity to engage in some dialogue with our team moving forward. But we'll certainly have some questions answered today as well. So thanks very much.